Hello, and take a look at this last kind of application problem for systems of linear equations. So first of all, let's read this question. It says how many points of a 10% solution and a 50% solution must be combined to get 44 points of a 40% solution. So if we start with the question, it says right there, how many points of a 10% solution and a 50% solution must be combined, right? Means we have two unknowns. Okay, we don't know what are they. We don't know how much of the 10% solution, and we don't know how much of the 50% solution. So we don't know these two, right? So that's sort of the overall picture, but let's dive a little deeper and make sure we understand what this means. So consider that 10% solution, right? What does that really mean? So imagine that you had a container here and this held the 10% solution. So let's see if I can do this right here. I'm trying to divide this up into 10 equal parts. That's let's see, 1 2 3 4 1 2 3 4 5 6 7 8 9 and 10. Okay, so I don't need this top one there. Oopsie, took off too much. Okay, and all right, so 1 2 3 4 5 6 7 8 9. Oh, need another one. 10. So 10%. Now if you were staring at this and it was well mixed, you couldn't tell the pure 10% part versus the fluid that is floating in. But imagine that we had sort of some kind of X-ray vision and we could sort of see, and the 10% part was sitting right there, 1/10 of it. And likewise, we have this 50% solution right here, right? And it's a 50% solution, so that means half of this, if we had sort of X-ray vision, half of this would be the pure 100% undiluted solution, and the other half would be whatever else. So what we want to do is basically combine these two and create a new solution that has 40% solution to it, right? So 1 2 3 4 1 2 3 4 5 6 7 8 9 and 10, right? We want to create something that has 40% solution. That's 1 2 3 4 in it, right? And it's possible because after all, this 10 one's more dilute than the 50% one. We should be able to pour stuff in and so on. So observe two things. The complete amount of liquid must come from what you pour. Right? So however much you pour in from here and however much you pour in from there must equal the amount that's in this thing, in the mixture. Right? So if I were to pour, I don't know, 10 from here and 30 from here, well then that's going to have 40 in it. If I were to pour 20 from there, then I would have to pour 20 from here to have 40 pints in this mixture. So we know the mixture contains 40 pints. Now what about the strength of this, right? So if I were to pour 10 pints from this first one, then that's a 10% strength. So we are only going to pour, we're going to get 10 times 10% mixture, pure mixture. And if I were to pour the rest from here, that's 30. That's going to come in and give me 30 times 0.5, because it's a 50% strength of mixture into here. So understand that this mixture must come from the two things you're mixing. All right, so with that sort of explained, let's see how we could start on this problem. So I'm going to go back here and try and squeeze in the problem to the right there so that we can keep the question up there. So we don't know two things. So we'll start off by saying let X be the amount poured from the 10% mixture, and let Y be the amount poured from the 50% mixture. Now these problems, these mixture problems, are easiest done if you create a little table to organize your information. This table should have 4 rows, 3 rows, and the rows consist of the things that are being mixed, right? So in this case, we'll call this the 10% mixture, and this is the 50% mixture, and this is the combined. And the columns should consist of the amount you put. So in our case, this would be X and Y, and we know the combined amount is 40, and the strength. So this 10% mixture is a 10% strength, this is a 50% strength, and what we want the combined one to be is a 40% strength. And then the last column is the amount of pure mixture. And the way you get that, so if you pour X amount of this 10% strength, then the amount you have here of just the pure excuse me, liquid, it's like that. That's going to be 0.10x, and this is going to be 0.5y, and then this is going to be 0.4, because I know the numbers, times 40. When you set up this table, please be consistent, meaning this here will be all the amounts, then this will be all the percents, and this will be the percent times the amount, percent times the amount, percent times the amount. Don't be consistent on that. Now, you can easily get equations out of this. The amounts poured right there is going to give you one of the equations. You're going to show it's X plus Y equals 40. And this is going to give you one of the equations. The strengths poured must also equal out, right? So 0.10x plus 0.50y must equal 0.4 times 40. Now, of course, 0.4 times 40 we can actually work out and write that down. So 0.4 times 40 is equal to 16. So what we have here is two equations, x plus y equals to 40, 0.1x plus 0.5y equals to 16, and we need to solve this. So I'm going to use the addition method to solve this. So I'm going to multiply that first equation by a negative 0.1, and so if I did that, so that is going to give me negative 0.10x. This is going to give me negative 0.10y, and this is going to give me negative 0.4. I said negative 4 actually, not negative 0.4, negative 4. And then this is unchanged. And if I were to add these, 12, I can solve and find y. It's going to work out to be 30. So if I know y is 30 and the combined mixture was 40, so x must be 10. Okay, so now report your answers. So we need y was what? Y was the 50% mixture, so we need 30 pints of the 50% mixture and 10 pints of the 10% mixture.